All right, 2.9, we're gonna put it all together. Basically what we're gonna do is we're gonna utilize technology to figure some stuff out, because it says use technology. So we're gonna make it easy. This is a two-part video again. First part's gonna be really easy. We're gonna find patterns to be able to graph things efficiently. We wanna highlight features of the graph from different forms, specifically in this section, factored form, and how does it relate to the graph? So let's dive right on into it. Question number one, it says use technology to graph the function and find the vertex, y-intercept, the x-intercepts, and so on and so on. So this first equation right here, you're going to use technology. So I'm going to go ahead and I'm going to go to desmos.com. Shocker, I'm already there. I do need to go back to my computer. If you need to pause it a second and find Desmos. Did you pause it? Good. All right. So now what you need to do is you need to be able to just type in the equation. You haven't done anything yet. You don't have it graphed. You just need to type in the equation. Y equals, oops, I already have y equals. I need a parenthesis, x minus 1, x minus 1, parenthesis, did I put in some other character there? I need an x minus 1. Don't freak out if it puts a line in there. And then you need another parenthesis, what is it? X plus 3. X plus 3. And you need to close it. And you'll notice it brings up a quadratic function. Why does it bring up a parabola? Well, think this is a quadratic function. It's in factored form. We just got done talking about factored form. X times x, that's x squared. That's a quadratic function. So now that we've identified, we've plotted, we've used technology, we didn't have to graph it, whatever, it wants to know the idiosyncrasies of what's going on. What are my x-intercepts, excuse me, what's the y-intercept, what's the vertex? The vertex is going to be -1, -4. The y-intercept is going to be 0 and -3. And my x-intercepts are going to be 1 and 3. So let's just go ahead and put all that information in here. All right, my vertex, what was my vertex? I believe it was -1 and -4. How do I figure that out? I'm going to tell you how we figured that out in a second. My x-intercepts are going to be 1 and 0 and -3 and 0. We'll notice something about those in a second. And the y-intercept was 0 and -3. If I recall correctly, that's a horrible -3. Right? Line of symmetry. What's that line of symmetry? That line of symmetry should be x equals -1. Because remember, the x value of the vertex, line of symmetry end up being the same. All right, so now we come over here. We've plotted our points, 1, 2, 3, 4, just like the graph is. We have 1, 2, there we go. Boom, right there. We've graphed it, we've got all that information. Okay? And it wants you to go through and do the same thing with 2 and 3 when we get to question number 4. All right? So it's telling you to utilize technology to do all that. I want you to utilize technology and graph all these things and see if you can figure them out. All right? You should be able to. So go ahead and do 2 and 3, and then come back and I'm going to show you how we find some of this other information without graphing it. Because what if I don't graph it? How do I know? How do I know what's going on? I don't want to have to graph it every time I need to find this information. So pause and do. All right. You should have paused and graphed these pieces of information. Right? How am I going to find the line of symmetry? How am I going to find the vertex, the x-intercepts? Well, what you should know by now is if you look back at all three of these, between the line of symmetry, the x-intercepts, and so on, they give me factored form, first of all. What is the purpose of factored form? Factored form tells me almost what the x-intercepts are. So if you notice on the first one, it had x minus 1, but my x-intercept was +1. It said x plus 3, but my x-intercept was -3. And then down here, my x-intercept, it says -2, but my first x-intercept is 2. my other one at 6. Why is that? How is it that my x-intercepts are opposite of what they actually look like? Well, the reason why is because in order to find your x-intercepts, remember, what is the value of these 2 points right here? This point right here, I went out -3 and I went out 0. I went out +1 and I went out 0. Y is 0. So when you set each of these factors equal to 0, you're essentially saying 0, or y, my output, is equal to x minus 1, and you solve. You're setting each factor individually equal to 0. Well, how do I solve this? It's solvable by adding 1 to both sides, so x equals 1. If my input is 0, my output has to be 1. There's your first one. If I do the same thing, I get 0 equals x plus 3 for the other factor. I solve by subtracting 3. X equals -3. So if my input is 0, my output is -3. The x-intercepts are the opposite of what your factors are. Now keep in mind, this a value out here is a factor. But if we set 0 equal to 2, that doesn't jive. So I don't worry about that one. So when I come down to question number 2, if I look at this, I don't really have to do this mess every time. I can determine what my x-intercepts are by saying, oh, it's the opposite. 2 and 0, 6 and 0. So now I can come over here, 2 and 0, 3, 4, 5, 6, 6 and 0. All right, so these are the sides of my parabola. Now, how do I find the line of symmetry? Well, remember, the line of symmetry is halfway in between. So this is a total of 4 units, so halfway in between would be 2. All right, so there's 2, 3, 4, so that means my line of symmetry is x equals 4. The relationship between the x value of the vertex and my line of symmetry is 4, or the same, so that's 4. And now I got to figure out what's my y-intercept, what's my x-intercept, so on. Remember, your y-intercept is always 0 something. So now it's a matter of either, hey, I graph it and use technology to figure out that information, or what if I didn't have access to that? How am I going to do that? Well, remember, that line of symmetry is halfway in between. I know the x value of the vertex. I know an input. So if I know an input, I can find an output rather quickly. I just simply substitute, and this is where you have to pay attention to what you're doing. So 4 minus 6. So all I did was substitute my input value, and now I want to find my output value. And it's a couple of steps. 2 times 4 minus 2 is 2. 4 minus 6 is -2, not 6. All right, whole lot of 2's there. And now I simply have to multiply. Positive times a positive is positive. 4 times -2 is -8. So my vertex is at 4 and -8, which I'm just going to, that's probably wrong, but I'm just going to throw that down there for time's sake. Now, how do I find my y-intercept? You do the same thing except you input 0, right? So 2 times 0 minus 2 times 0 minus 6. And what do you get? You get 2 times -2 times -6. And remember, my graph is opening up, so I want my y-intercept is probably going to be a pretty high number. It's going to go up quite a ways. So 2 times -2 is -4, and then you get -4 times -6, which is positive 24. So is that sensible? Yeah, because my y-intercept is going to be way up here. So that's sensible. So that's how I can find that information without it. And this is where we get to question, and we're almost done here. This is where we get to question number 4. Based on these examples, how can you use a quadratic function in factored form to find the line of symmetry? That's easy. It's halfway between x-intercepts. That's simple. How do you find the vertex of the parabola? Well, we plug in, let's see, what did I put on my notes? Basically, we're going to plug in x, plug in the x value, of the vertex, which we know is the line of symmetry, okay, and solve for y. How do you find the x-intercepts of the parabola? We're going to set factors equal to 0 and solve. That's how we find the x-intercepts. How do we find the y-intercept of the parabola? we use 0 to substitute and solve for y. How do we find the vertical stretch? What designates stretch or shrink? The A value. That designates stretch or shrink. So we have to keep that in mind when that's happening, right? So knowing that information, okay, try 5. Now what I'm going to do, what I'm going to tell you about 5 is, and try 5 on your own, what I'm going to tell you about 5 is look at it. It's in standard form. The only thing I get out of standard form, what's the only thing I get out of standard form? 2 things we talked about. A, which is stretch or shrink. So my A value is 1, my B value is -2, and my C value is -8, which B doesn't tell me anything about my graph. But C tells me something about my y-intercept. Do you remember what it is? Yeah, the C value is my y-intercept. Now, convert it to factored form. Use your box. Okay? Use factor by grouping, whatever you're going to do. And you will get the factored form. You'll be able to use the factors to find the line of symmetry, to find the vertex, to find the x-intercepts. If you know factored form, it wants you to list it. You know the x-intercepts. The vertical stretch you already know. Gee, that's 1. So we've answered tons of information without even really doing anything. All right? And you know the vertex is at least the x value of the vertex is halfway in between. So x value, vertex, line of symmetry, same thing. All right? So there's part A, and we'll come back later for part B.